Now we should look at this one here, that 1 over x, because why can't we just apply the power rule? We did that power rule here and here. Why 1 over x? Well, 1 over x is kind of special. We're going to see that it's kind of special because it shows up in later on in calculus too. It's kind of a special function. So what happens? Why can't we apply the power rule here? So if we try to apply the power rule, okay, so we have x to the power -1. Okay, we can try to apply the power rule. We get this. We increase the power by 1, x to the power 0. Well, that's not a huge problem, because anything to the power 0 is just 1, and that's possible. Problem is, we're going to divide by 0. This is a big problem. Okay, this is a big problem. We can't really divide by 0. We shouldn't be dividing by 0. So we can't apply a power rule here. We can't apply power rule. Good thing for us, there is a place for 1 over x, and the 1 over x does differentiate it, or anti-differentiate into log x. Okay, so there is a place for it, but it doesn't fit with all the other powers. It's a little bit special that way. It's a little bit different. Okay, and we're going to see that it is kind of a special function. It does show up in infinite series when we get to that later on. Okay, and well, you may or may not get to that, but it is very special. The 1 over x is a special thing that we have to be considerate of. Y plus c. Well, the plus c we talked about. Well, if you think about from the derivative perspective, there could have been a plus c that disappeared when we found the derivative. Okay, but we could also think of this as when we anti-differentiate. Okay, there are all these plus c. So the difference in the plus c would be when we anti-differentiate. This plus c means all it is a vertical shift. Okay, it's just a vertical shift. And the derivative is telling us only one thing. It doesn't tell us the position of the original graph. It just tells us the slope of the original graph. If I look at the slope of the original graph, let's say the plus c was, in this case, I think it was plus 5. That's a plus 5, right? There's the slope. And if we look at plus 0 slope, the slope at that same point at x equals 1, the slope of plus 0 gives us the exact same slope as the red line. And if we look at the slope of -5, okay, at x equals 1, again, exact same slope as the -1, or sorry, as the 0 and the plus 5. Okay, so this slope at that same x coordinate is going to give us the exact same slope values. And in fact, if we just look at the rest of this graph, like every single x coordinate, they're going to give us the exact same slope. So that plus c just gives us, all it does is give us vertical positioning. So it has no effect on our derivative function. So when we anti-differentiate, we do always have to account for that plus c, because that plus c could have been there and we just didn't know about it. It's just because it was just a vertical shift that doesn't affect differentiation.